Hello, welcome to Mr. Jesse's video tutorial in physics. This tutorial is about combination of capacitors. Consider the illustration. We have four capacitors that are combined in a complex manner. So let us label each capacitors first. We'll have C1, C2, C3, and C4. Notice as well that we have terminals A and B. Now charges can either go from A to B or from B to A. So for the sake of this analysis, we'll consider that charges are moving from A to B. As charges move from A, they would enter this junction here. Some of the charges would go up and others would go down. For these charges that are going up, we could now treat the capacitors like resistors, so that for these charges that are actually going up, they would have to pass through capacitor C1 and C2 before it would reach this junction here. So in this case, we could actually see that capacitors C1 and C2 are connected in series. Hence, we can simplify our circuit into something that could look like this. We have junction A, capacitors C1, C2, other junction, capacitor C4, and this here would be our C3. So let's label our capacitors. We now have C1, 2. This one down here would be C3. And this on the right side would be our C4. Now as charges move from this junction here to the opposite junction, some of the charges would go through C21 before reaching this junction here, and others would pass through C3 before reaching this junction. Then we could say that capacitors C1 and C3 are actually in parallel, and hence we could simplify our illustration further so that we can have something that could look like this. Wherein the first capacitor is C1, 2, 3, and this other capacitor is C4. So obviously C1, 2, 3 and C4 are connected in series. They're connected in series, and then eventually we will have our equivalent capacitance that is just going to look like this. So we call this C total, which is just equal to C1, 2, 3, 4, or simply the equivalent capacitance, or CEQ. Let me just arrange these illustrations. There you go. Alright. Now if the objective of if the objective is for us to be able to find the charge in each of the capacitors or the voltage in each of the capacitors, it is very important that we have to work our way backwards. So for example, in order for us to be able to solve for charge 1, charge 2, charge 3, and charge 4 for each of the capacitors, we will have to start with at the total capacitance. What do you mean by that? So here we have our total capacitance, and more often than not, the total voltage would also be given. So here we will have our total voltage Vt. So since we have our total capacitance and we have our total voltage, then we could actually solve for Qt, and that is just equal to Ct times Vt, or the equivalent capacitance multiplied by the total voltage. Then we move our way backward to this illustration. Notice that C123 and C4 are actually connected in series. This means that the total voltage would just be equal to the total charge would just be equal to the charge in 1, 2, 3, and that is also equal to the charge of Q4. So hence, if we have C123 and Q123, then we could actually solve for V123. Moreover, if we have C4 and we have Q4, then we could also solve for let me just change the color. So we could also solve for the voltage of capacitor 4. And to solve that, we just have to use the formula that Q4 is equal to C4. And then after this, we will have to move up. So we would analyze this illustration now. So taking into consideration that C12 and C3 are actually parallel with each other, so therefore the information that we could carry over would be that the voltage of charge of capacitor 1, 2 would actually be equal to the voltage of 1, 2, 3, because the voltage of 1, 2, 3, or capacitor 1, 2, 3 is actually a combination of capacitors 1, 2, 3 is a combination of capacitors 1, 2 and capacitor 3, and they are connected in parallel. So once we have voltage 1, 2, 3 and voltage 1, 2, and we also have capacitance 1, 2, then we could have Q. Let me just change the color. Then we can actually have Q1, 2. Also, if we have C3, then this means that our V3 is also just equal to V1, 2, 3. And now we actually have C3 and we have V3, then we could solve for Q3. So far we actually now have our Q4. We also have our V4. We have our Q3, and we also have our V3. Moving on, recall that C1 and C2 are actually connected in series. So I'm talking about these capacitors. So we have C1 and C2. So again, C1 and C2 are actually connected in series. So therefore, we could say that Q1 would just be equal to Q12. Q12. Also, Q2 would also just be equal to Q12. Again, this is because capacitors C1 and C2 are actually in series. Now that we have C1 and Q1, then we could solve for V1. And also, since we have C2 and Q2, then we could solve for V2. And then, this means that we now have Q1, Q2, we also have Q3 and Q4. Similarly, we also have V1, V2, V3, and V4. Then we have solved the problem. Thank you. So we could now look for our V1 and V2.